Hello, my name is Darren Thomas. I am the Director of Educational Research Techniques. In this video, I'm going to provide an example of how to solve or how to find the standard deviation for a sample. So why don't we go ahead and move to the next slide. So here's what we're going to do. I'm going to do this for a very small sample. So let's say I have a sample and maybe this is like the average score on a quiz or something. It doesn't really matter. That's not the point right now. Let's just say I'm looking at the average score on a quiz or something, out of 10 points, if you will, and I get the following scores: 7, 5, 3. Now, I don't want the mean, although I need to find the mean as I go through this process. What I want to know is I want to know what is the standard deviation. In other words, what is the average distance of any given example from the mean? That's what I want to find here. So the first step in finding the standard deviation, but before I even do that, let me just draw you the equation here of what it looks like, and then I'll go through the process here. So the equation is as follows. For the standard deviation, it is as follows: the square root, and then you have the sum sign here, and then inside that you have x, that's your whatever example you're working with, x bar, or the mean. All this is squared, and then all this is divided over, let me make this a little bit longer here, n minus 1. So this is our equation right here. So you can see there's several things going on. Number one, I need to find the mean. That's going to be one of my goals here, and that's the first step in doing a standard deviation. So you must understand what the mean is. After that, I need to subtract the actual individual values here, sum them all up and square them, and then I'll be able to divide over that and then square root it. That's kind of how it works. So that's the equation right here as follows. So why don't we move to the next slide and I'll go through the process here. So here are my sample examples here: 7, 5, 3. Now, as I just showed you on the previous slide, I first need to calculate the mean. And so the mean is very, very simple. We'll just do it down here in the corner. It's not that complicated. 7 plus 5 plus 3. We add them all together and then we divide by 3. Why do we divide by 3? Because that's how many numbers we have here. 7 is one number, 5 is our second number, 3 is our third number. That's our sample size right here is 3. And so if you do this, 7 plus 5 is 12, 12 plus 3 is 15, 15 divided by 3 is 5. So in other words, our x bar, if you will, is going to be 5. X bar stands for the mean. Now the second step that you do here is you need to subtract the individual example, we can also call them an observation, from the sample mean. So 7 minus 5, 5 minus 5, 3 minus 5, excuse me. So 7 minus 5, that comes out to 2. 5 minus 5, make this a little bit neater, comes out to 0. 3 minus 5 comes out to negative 2. So we're almost done. Now, the last thing you want to do is you want to square the results of this particular this difference here. Because right now, if we add things together as they are, they're going to cancel each other out. Because 2 plus 2 is 2, 2 plus 0 is 2, I'm sorry, and then 2 minus 2 becomes 0 again. So we have to square these so that we are able to keep the difference here. So if I square this, and square this, I end up with 4, 0 again, and 4. Now we're very, very close to being done. One of the last steps that we have to do now, and let me just go back and show you, is we need to add up what's left over, so that'll be 4 plus 0 plus 4, and then we need to divide it by n minus 1. That's our final step there. So, as you know, 4 plus 0 plus 4 is 8. So we're going to do 8 here. And then over 8, we're going to have 3 minus 1, which comes out to 2. All right, so we're very, very close to finishing. Let me go to the next slide here. So now I have 8 over 3 minus 1, which comes out to 2. And so our answer right now is 4. That is our answer. Now this answer, we call it the variance. In other words, this is like the standard deviation squared. That's what it is right now. But we're not quite done. And so to get our final answer, we have to square root this 4. So if you know, again, if you were an A student, you knew the standard deviation just from looking at the sample that I put on the screen. The square root of 4 is 2, which means that this is the standard deviation right here. The number is 2. And so depending on what you're working with, the standard deviation can be either an S or a sigma, depending on if you're working with the sample or the population. So either one. And in this case, the answer is 2. Since we're using a sample, it's going to be S, not sigma. All right, so this is how you do it. This is the process for calculating the standard deviation. Now, I just want you to understand, what is the standard deviation telling us? It is telling us the average distance from the mean. And you can see this clearly again. For the A students, you saw this immediately. We know, because I already calculated this, that the mean is 5. And so what's happening here is that what is the average distance of any given point from this mean? Well, if you look, 7 has a distance of 2 from the mean of 5. 3 also has a distance of 2 from the 5, of 2 from 5. And so this is why our standard deviation is 2. Because if you look at it, 7 is 2 points away from 5. 3 is also 2 points away from 5. 5 is not going anywhere. It's right there in the middle. And so this is why our standard deviation is still 2. You can see the average distance from the mean is 2 in this particular example. That's how it works. And so this is what the standard deviation tells you. It's one of the measures of dispersion that we use in statistics. So I hope that this video was useful for you, because in this video we learned how to calculate the standard deviation, which is a measure of the distance of the average distance of any given example from the mean. Again, we say on average, not all expected distance, if you will. And so to do this, you have to first calculate the mean, and then after that you subtract a given example from the mean, and then you square that result and add it together. After you do that, you divide it by n, or the sample size, minus 1 to get the actual the variance. And then once you get the variance, you square root that value, as you saw in the last slide here, to get the actual standard deviation. And again, like I already told you several times, this is the expected distance of any given point from the actual mean, which you can see in this example, like I've already said, 7 has a distance of 2 from 5, and 3 also has a distance of 2 from 5. 5 is not there because 5 is the mean. This is one reason why we subtract the n from n minus 1 right there. So, I want to thank you for listening. My name is Darren Thomas. I'm the Director of Educational Research Techniques. Take care.